dear students, welcome back to 60 out of 60 in KCET Chemistry 2025 series. So today we are going to complete this chapter. Finally, we are going to end this chapter by doing the last topic of this chapter, that is your reactions and the preparation of benzene. Okay, so let us quickly start and finish this chapter. So we have already completed this part, right? So we are on the part 10th, that is today we are going to discuss about this year wise weightage is also there. Okay, before that a small announcement. So students, you will be knowing that we have our PU2 success blueprint test series, okay, and this test series is designed to help you to boost your preparation, to help you to get 95% and above in your final board examinations. Okay, so in this you will be getting 12 mock tests, which includes 12 4 part tests and 8 full length papers. You will be getting one shot revision videos, doubt clarification, live classes, as well as you will be getting video solutions with a detailed explanation, and all this is available at just 599 rupees. Okay, so please students, do not miss this opportunity. The link is there in the description section. Please go there, click on the link and buy this test series as soon as possible. Okay, so now let us move forward. So in today's class we are going to see the first thing, that is your electrophilic substitution reaction, under which we will be seeing nitration, halogenation, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. Okay, after that we will be seeing addition reactions and then combustion reactions. Okay, so let us see first one, the nitration part. Okay, so in nitration reactions, see okay, what do you, first of all let us understand, when we have a phenyl ring, okay, now I told you that this ring, okay, this ring has what, this has pi electrons, and we know pi electrons can delocalize, means they are free to move. Now because these pi electrons are able to move, okay, that means we can say that benzene ring has extra electrons present, okay, or the electron density is more. Okay, now that is why benzene behaves as a nucleophile. Okay, now if benzene is behaving as a nucleophile, then what will happen? If benzene is behaving as a nucleophile, it will attack on electrophiles. Okay, and we also know what is nucleophile and what is electrophile. Nucleophiles are electron rich species, electrophile are electron deficient species, right? So first of all we have to understand that benzene itself behaves as a nucleophile. Okay, due to what? What is the reason? Due to the presence of pi electrons. Okay, so let me now tell you nitration if I want to add. So if I want to do benzene, if I have benzene and if I take the reagent concentrated HNO3, okay, and concentrated H2SO4, in the presence of these two reagents, what will happen? NO2 group will be attached to the benzene ring. Okay, NO2 group attaches to benzene ring, and what is the electrophile here? The electrophile is NO2 plus. Okay, next coming to halogenation reaction, means if you want to add any halogen. So if I take for example Cl2 in presence of AlCl3, or if I take Br2 in presence of FeBr3, okay, then what will happen? I will get chlorine group attached here and I will get bromine group attached here. Okay, so this is bromination and this is chlorination. Okay, clear? Next coming to we have sulfonation, means addition of sulfuric acid group. So you can just take benzene ring and concentrated H2SO4. Okay, so if you take this, what will happen? You will get SO3H group attached here, and this is called as sulfonic acid. Okay, next we have Friedel-Crafts alkylation. So this is a name reaction. Alkylation means adding an alkyl group to benzene. Okay, so if I have this benzene ring, okay, and I want to add alkyl group, so you have to take CH3Cl AlCl3. Okay, and here you will add CH3 group here. Okay, and what is the cation produced or electrophile produced here. Electrophile is CH3 plus. Okay. Now similarly you have Friedel-Crafts acylation. So if you take benzene ring, okay, and you can do like this CH3COCl AlCl3, or you can use CH3COO one second, CH3COO COCH3 in presence of AlCl3. This one will give you COCH3 and also COCH3. Okay. So when you are adding this COCH3 group, this is called acylation, or acyl group is added. And what is the electrophile produced here? Electrophile is CH3CO plus. Okay. Now see, CH3COCl, okay, this compound structure is like this, okay, and this is called as acyl group or acyl chloride here, okay. And if I take this structure, that is CH3 C double bond O, okay. So using this reagent also we can get the same product, okay, and this is called as your acetic anhydride. Okay. Now one more thing, if I just move back, yeah, in halogenation what are the electrophiles? Here Cl plus is the electrolyte and here Br plus is the electrophile. Now let us quickly understand how this electrophile is produced. Now what you are taking here, Cl2, okay, plus AlCl3, right, and we know that AlCl3 is a Lewis acid because its octet is not satisfied. So what does it take? It takes this Cl and this bond, this Cl bond breaks, this Cl is taken by this one, so we get Cl plus and AlCl4 minus. Okay. Now this Cl plus which is formed acts as an electrophile here. Okay. Next we have, okay, now coming to addition reaction. So addition reaction, you can add simply H2 and nickel, so all the bonds are broken and we get cyclohexane, okay. And if you add chlorine 3Cl2 in presence of UV, excess of chlorine, then we get benzene hexachloride, okay, benzene hexachloride. Next is combustion reaction. Combustion reaction is very common, just you have to take oxygen, you will get carbon dioxide and water. But here something which is important to remember is we get sooty flames, okay, and the reason for this sooty flame is unsaturation, right. You should remember, we have discussed in previous chapter also, saturated carbons burn with a blue flame and clean fuel, whereas unsaturated compounds burn with a sooty flame and yellow flame, right. Okay. So next coming to this one, directive influence of functional group. This is very important, but before that I want to discuss something else, that is preparation. Okay, we missed this one, so I want to discuss preparation of benzene. Okay. Now see, for preparation of benzene we have already studied one method, and that is your yesterday only we studied in the ethyne one, like cyclic polymerization of ethyne. So if you remember 3 times of, so first method I will write like this, yes, first method is cyclic polymerization, cyclic polymerization of ethyne. So if I have like this, okay, 3 times of ethyne in presence of Fe, red hot tube, we used to get benzene, right. So this is the first method. Now second method is reduction of phenol. Reduction of phenol. That means what? You have this one, phenol plus zinc will give you benzene. Okay, so these are 2 methods of preparation of benzene. Now we will go to something called as directive influence of functional group. So first let us understand what is the meaning of this. Okay, now see, first let us understand the meaning. Suppose suppose you have benzene ring, okay, and one group is already attached to here. Okay, one group is already attached to the benzene ring. Now you are adding one external group X. Okay, you want to add this group X. Now according to this group, these are the ortho positions, these are the meta positions, right, and this is the para position. Now this group X will attach on ortho, meta or para will depend on the nature of this group or this functional group which is already present in the benzene ring. Means this is suppose incoming group, okay, this wants to come, so this is incoming, okay. So this existing group, this existing functional group will direct this incoming group whether to go to ortho, meta or para position, okay. So that is called directive influence of a functional group. So based on this functional group, it will direct, it will give advice or it will give the direction to this incoming group to go to which position, okay. Now on what factors? So there are two types, it can either direct to ortho or para or it can direct to meta directing groups, okay. So the group, incoming group X, whether it will go to ortho or para or it will go to meta position will depend on the functional group G present here, okay. Now we will understand it in detail. Now ortho, para, those groups, those functional groups, which type of functional groups will direct the incoming X to ortho and para position, okay. So first of all, let us take a small example of OH, okay, phenol group. We all have studied resonance, right? Oxygen is having this lone pair of electrons. So what happens, that resonance takes place. So this electron will come here and this bond will shift here. So now what will happen if I draw the next resonating structure, okay, this bond has shifted here. So one second, okay. So here I will get, now see, this bond has come, this electrons has come here, so double bond will come. Now oxygen is having, oxygen has donated both of its electrons, so it will gain a positive charge. These electrons are shifting here, so this is getting a negative charge, right. Next what will happen, this will move here and this will move here. So what I will get, I will get this negative charge here and this one, okay. Next I will get this one and this one. So I will get structure like this, one second, this one, okay. So this one will come here and we will get O plus and H. Next what will happen, this one will come here and this one will come here. So we will get a structure like this. Okay. So now you see, if you see the entire this resonating structures, where do you find the negative charge has come? Negative charge has come at ortho position, and negative charge has come as para position, and again negative charge has come at ortho position, right? Ortho, para and ortho position. So what does it tell you? That this benzene ring will behave as a nucleophile, we know, right? So the incoming electrophile, okay, the incoming electrophile will go to those positions where the charge density is more. Now we find that in case of phenol, if I take this group as OH, it will direct the incoming group to either ortho or para position because there the electron density is more, okay. So that means what I can say, OH is ortho para directing. So now how to understand this one? Suppose I have a reaction like this, see, suppose I have a reaction like this, I have taken OH, okay, and now suppose I want to do Friedel-Crafts alkylation, okay. What is the electrophile here? CH3 plus, right. So now what will happen, this, because it is ortho para directing, this CH3 group will go to ortho position and para position, and we will get two products like this, OH CH3, okay, plus OH CH3, okay. So that is, so you can see that CH3 is not going to the meta position. Why? Because their electron density is not there. Electrophile will be going or attracted to those positions where the electron density is more, Okay, so there can be certain more orthopara directing groups. You should be knowing their list. So NH2 is also orthopara directing. NHR, NHCO, CH3, OCH3, CH3, C2, H5. These all are your orthopara directing groups. Okay. Next, moving towards the meta directing groups. So let me take you another example where I'll draw the resonating structures of NO2. Okay. So now what will happen? You see oxygen is more electronegative, so oxygen will pull the electrons, so nitrogen will pull electrons from here. So what I'll get? O minus, here O, here N double bond, and this bond has shifted here, so here it is positive charge. Okay. Next what will happen? You will see one more group. This bond can shift here. Okay, so we will get positive charge here, this is shifted here, and this one is like this. Okay, next what will happen? This one will come here, positive charge will come here. Okay, so we will get this one, positive charge here, and then NO minus. After that what will happen? We can find this one can come here, this one can come here, and I'll get the structure like this, like this, N O. Okay. So now what do you see here? See, at ortho and para position, positive charge is coming. That means what? These positions or these places are electron deficient in nature. Okay. These are electron deficient species or electron deficient positions. Now, if this nitro group is there, electrophile wants to come. Now, will this electrophile go here? No, right? Because it wants electron rich species, electron rich center, because it is an electrophile. So, in case of NO2, the ortho and para positions are electron deficient. Then which is the electron rich comparatively? You find that the meta position where there is no positive charge is there, these are the comparatively electron rich species. So in that case what will happen? The electrophile will go and attack here. So let me take you an example here. So suppose I have this compound, okay, or suppose I have this compound NO2, okay, and then suppose I am adding here CH3Cl AlCl3. In that case what will happen? The NO2 group will direct, because it is a meta directing group, the CH3 will attach here, right? And in the previous example you saw if OH was there, it was attacking, we are getting two products where ortho and para were substituted, but here it will be meta. Now let me say you some other examples. So NO2 is your meta directing group, CN is meta directing group, CHO, COR, CHO means aldehyde. Here it is ketone group, acid group, then ester group, SO3H. These are all your meta directing groups. Okay. So here is the concept of ortho-para directing and meta directing groups. Now one more thing you should remember, that this ring, this OH, suppose these are what it is donating electron to the ring. So these type of or ortho-para directing groups are called as electron donating groups. Electron donating groups, or I can say that the electron donating groups are ortho-para directing. Okay. Next, meta directing groups are your electron withdrawing groups. Okay, clear? Fine. So these are the examples of electron withdrawing groups. So yes students, that's all in this class, in which we have discussed regarding the preparation, regarding the chemical reactions, and the very important topic, that is the directive influence of functional groups. Okay, so these are like the last part. The directive influence of functional group is very important. So make a table of electron donating groups and electron withdrawing groups, and you should remember these examples. Okay, so yes students, that's all, and I hope you have liked today's class. Thank you for watching, and please do not forget to subscribe the channel.